Hello everyone, this is David Matkin, and this is a follow-up video to part one on taking a present value and calculating the future value. And if you haven't watched that video, I recommend you stop and go watch that video. It's about 10 minutes and it's an important precursor to what we're doing here. My purpose in this video is to introduce to you Excel's time value of money functions. You're going to want to learn how to use those functions because they're going to add a lot of functionality to you and simplify your life when you're doing more complicated calculations. At this point, the algebra equation is perfectly adequate, but it's helpful to learn how to use the Excel function with a relatively straightforward calculation. So let's have a little orientation to the function here and start using it regularly. Now what you see on the screen is a template for how I recommend you lay out your time value money calculations. You don't have to use this template exactly as I have it laid out here, but you'll want to use something similar to this because it's going to help you make fewer mistakes and replicate your work. So let's look at this question. The question asks us to identify the future value of $10,000 today over 40 years with a time value of money of 8%. Let's start by identifying what we're trying to calculate. And that's the future value. We want to know the future value. So I'm going to highlight the future value cells just to recognize that's where the answer is going to go. Now I'm going to enter in the inputs that are given in the question. We know that the APR is 8%. We know that the years are 40. We know how often we compound per year. In this first column, we're going to compound the calculation annually. So that just means compounding once a year at the end of the year. But in column D, we're going to calculate quarterly compounding. We're going to put 4 in there as the number of times we'll compound in a given year. Now, none of this information here is going to be entered directly into Excel's time value of money function, but this is going to be used to calculate those inputs. And that's why these cells are highlighted green, so that I remember I'm going to enter in a formula. And what I need to do is calculate the rate per period. And so this is compounding annually, and so the periods are years. So what is the interest rate? Well, it is the annual interest rate, but I'll take the APR and divide it by how many times I'm compounding per year. With an APR of 8% compounding annually, then the compounding per period, which is per year, is not surprisingly 8. But when we are compounding per quarter, now it's not 8% per quarter, it is 8% divided by 4. And so it's going to be 2% per quarter. And I'm just moving that decimal place over so that I can see if there's any kind of rounding. Now, over how many periods will this compounding occur? Well, in this case of annual compounding, well, I'll take the 40 years and multiply it by how many times we're going to compound per year, which is 1. So we have 40 periods. But with quarterly compounding, we have 40 years still, but now we have 4 periods per year. So this is a different scenario because annual compounding gives us 8% growth 40 times, but quarterly compounding gives us 2% growth 160 times. And this difference is important. Over a long period of time, it's going to have a material effect on the solution, on the calculation of the future value. Now let's put in the present value. It's $10,000. That's how much we have now, or at the beginning of the 40-year period. I'm going to change the formatting here to accounting. Okay. Now we have these 2 bits of information about annuities. And an annuity is a cash flow that occurs every period. So that would be some cash flow that occurred every year in this annual compounding or every quarter in this quarterly compounding. And we don't have anything. There's no additional amount that's added or withdrawn from this $10,000. And so we're just going to put 0. And we'll once again change the formatting to accounting. And the type information refers to whether the annuity occurs at the beginning of every period or the end of every period. And this doesn't matter because the annuity is 0. So it doesn't matter whether $0 is seen as occurring at the beginning or at the end because it has no effect. We'll talk more about annuities soon, but for now, just focus on what we've got up here. So now we're ready to do this calculation. We come in here to the future value cell and we choose the function of FV. So what is the rate? Well, we calculated the rate up here as 8%. That's rate per period, not per year. Rate per period. All the information in here is now dealing with periods. Now the number of periods is 40. The annuity value is 0. The present value is 10,000. And the type here is 0. So what we see here is that the future value of $10,000 given 40 periods and 8% time value of money per period is $217,245.21. Okay, so what about quarterly? Well, if we've entered in all of these references correctly, we should just be able to drag this formula over, and now Excel will look at the inputs for the quarterly compounding column. And we can see that if the compounding occurs quarterly, even at the same APR, we end up with a higher future value. In this case, $237,699.07. Okay, so hopefully most of that was fairly straightforward, but there's one last item that people over the years have found to be a little confusing, or maybe a lot confusing, that we need to talk through. And the sooner you can kind of wrap your brain around this, the better off you'll be. You may have noticed that we gave an input of a positive present value, but the future value function returned a negative future value. Why is that? Well, the answer lies in the underlying assumption of the time value of money function. The function assumes that we're looking at one side of a financial transaction between two parties. By entering the present value as a positive value, we are taking the perspective of the party that's receiving a cash inflow today. And therefore, Excel says if you receive this inflow today and the time value of money is 8% APR over 40 years, you're going to have an outflow of these amounts that we've calculated, 217,000 or 237,000, depending on whether the deal is anticipating annual compounding or quarterly compounding. If we want to take the other side of the investment, all we have to do is make these values negative. And you'll see that the numbers didn't change. It's just whether they are positive or negative changed. So now this party is making an outflow in the present in anticipation of an inflow in the future. Okay, that's enough for now. I hope that's helpful.